Hi, welcome to the YouTube channel of Gravitas Edtech. Today we are going to learn trick to find bond order. Okay. Normally, how we used to find that bond order, we used to write the electronic configuration, that is sigma 1 is to sigma 2 is to sigma star 1 is to. Okay. Again sigma 2 is to sigma star 2 is to, again pi to px to py. Okay. So this becomes very lengthy and it will become time taking for a single question. So we have come up with a new trick, that is bond order equals to half of, we have to write only 2 2 2 2 and 6 6. Okay. So the left portion of the what we can say, this column represents what? Your BMO, bonding molecular orbital or electrons, and this column shows your ABMO or anti-bonding molecular orbitals, or you can say electrons. Okay. So if we have to find, let's say, find the electron bond order of any compound, that is NO. Okay. Let's say we have to find the bond order of NO. So the electrons in NO, nitrogen is 7 and in oxygen is 8. So 7 plus 8, 15. So how we find? Okay. So bond order equals to half. So we have to fill how much electrons? 15 electrons. So we write 2, 2, that is 4, plus 2, 6, plus 2, 8, 8 plus 6, 14, and 14 plus 1, 15. Okay. And the bond order is the difference of the last row divided by 2. Okay. So this row, how we calculate? So bond order equals to 6 minus 1 by 2, that is equals to 5 by 2 equals to 2.5. Okay. So this trick is a very easiest trick way to find the bond order. Here you do not have to write what? Electronic configuration again and again. You can simply find the bond order of any element, okay, or any compound. So let's see more examples. So we are taking now NO plus. Okay. So Na plus is how much? 7 plus 8 minus 1, that is your 14 electrons. How we will find? Bond order equals to 1 by 2, 2 plus 2, 4 plus 2, 6 plus 2, 8, and 8 or 6, 14, 0. Okay. So we have to stop here and we have to find the number of electrons, the difference in number of electrons in the last row, that is 6 minus 0 by 2, that is equal to 3. Okay. And it is correct because we know that NO plus is equivalent to N2 and N2 contains 3 bond. Okay. So the bond order is 3. Okay. So let's take one more example. The next example will be your NO plus 2. Okay. So NO plus 2 will how much? 7 plus 8 minus 2, that is your 13 electron. Okay. So bond order equals to 1 by 2, 2 to 4 to 6 to 8 to 8 plus 5, 13, and then 0. So bond order again comes out how much? 5 minus 0 by 2, that is 2.5. Okay. If if it is asked that in between NO and NO plus, which one is more stable? Okay. So what we have said, that this is your BMO part and this column is your ABMO part. So you can see exactly that in the NO we have one electron in ABMO, and in NO plus 2 we do not have any electron in what? ABMO. So we can directly say that, what we can say, that NO plus 2, sorry, this is NO plus 2. The NO plus 2 is more stable than NO because it do not have ABMO electron, and we know ABMO, what ABMO do? It destabilizes the molecule and increases the energy. Okay, so by this trick you can find the bond order, and as we know that bond order is directly proportional to bond energy, and the bond energy directly proportional to bond stability, and inversely proportional to what? Bond length. Okay, so you can find everything that you want by this trick. Okay, hope you like this trick. If you like this trick, please subscribe our channel for more such videos. Thank you.